Hi class, it seems that you're having some issues with word problems. As we expected, they're challenging, and there's no one single solution for every problem. Let's take this question 10 about air travel. We have a jet leaving North Carolina and traveling at a rate of 564 kilometers per hour. Another jet is leaving a half an hour later. Now, this one, a few things you want to watch out for. Both jets are traveling at the same direction. Okay? And again, getting the information into some form of chart, picture, graphic will help you to organize your thoughts a little bit. So we have the first jet here that's traveling at 564 kilometers per hour. Okay? And then the second is 744. But it is traveling 1/2 hour less. Now, it's important to keep your units similar. Since we have kilometers per hour for the rate of our airplanes, our jets, then we want to also use our time as in hours. Therefore, I'm going to say the time for the second jet that leaves later is going to be t minus 1/2. That's the most important key to this question. The time for the second or the first airplane will just be t. So now I have a rate. And a time of t for the first airplane, the first jet, and then I have a rate and a time for the second airplane of 744 and then t minus 1/2. In the problem, we see they're traveling the same direction, and we want to know when the second jet will overtake the first. That's the key to this question here. So we can set up an equation in which the distances are equal. They're going to the same place. So our equation of 5, 6, 4 t equals 7, 4, 4 times the quantity, okay, times the quantity t minus 1/2. Please don't forget to distribute that 744 to the 1/2, and you'll get something like 377. Okay, I'll leave the rest of this problem for you to finish. If you have issues finishing it, you can see me in class. Here we're looking at airplane travel again with question 12. Now notice we're flying from New Orleans to Atlanta, Georgia, and then back. Okay? The airplane is, when it travels to Atlanta from New Orleans, okay, so here's Atlanta, and here's New Orleans. When it travels to Atlanta, it's traveling at 320 miles per hour. Coming back, it's traveling at 280 miles per hour. And a lot of these problems will talk to you about wind speed and how if you're traveling with the wind or against the wind, your speed will be slowed down quite a bit. So in this case, we've got the faster rate going to Atlanta. It's a little slower coming back. And the total trip is 3 hours. So we know the distance, right? We know the distance from New Orleans to Atlanta, and then the reverse is going to be the same. So we're looking at a equal distance equation here. The big thing is the time. The total time is 3 hours. So you want to ask yourself, well, if it took me an hour to get to Atlanta, then I have 2 hours to get back. Or if it took me 2.5 hours to get to Atlanta, I only have half an hour to get back to New Orleans. So that 3 hours is the key here. If we say one part of the trip is X, for its time, then the second segment of the trip is going to be 3 minus x. And this is the math that you are doing in your head when I asked you, well, if the trip took you an hour to get there, how many hours do you have to get back? So you have to ask yourself, what's the obvious question here? Hopefully we can see that the x and the 3 minus x is going to give us our time for the to Atlanta and then back. So we then set up an equation, again, distance equals rate times time. We have a rate and a time for both situations, coming and going. So therefore we can just multiply our rate of 320 miles per hour times our time of x, and that should give us, because again, we're going to the same place and back, 280 times the quantity here, 3 minus x. We can then distribute. Again, be very, very careful. You are distributing properly. Make sure you take the 280, multiply it times the 3, and then multiply it times the x. That's going to give you a negative 280x over here. Combine like terms and solve. Good luck. Here's the answers at the top for you to look at and compare your results. Hi again, we're looking at question 18 right now. You can see here we have Ellen and Kate riding their bicycles to the library. Again, they're going to the same place. One's traveling a little faster than the other in this point. So if we look at Ellen riding her bike at 12 miles per hour. Okay, so here she goes riding her bike at 12 miles per hour. And this is Ellen over here. And then Kate is also going the same direction, but she is a little slower at 9 miles per hour. Ellen gets to the library 15 minutes before Kate. So we have to ask ourselves, which girl do we want to assign X as the time, and then which girl we want to assign X plus 15 or minus 15, it depends. And again, our units here, we want to think about the fact that our rates are in miles per hour, and we're told this 15 minutes. So we have to keep our units consistent. Some problems it will affect the answer, and some by luck it won't. So we have to, I want you to be consistent with your units as much as possible. Since Ellen got to the library before Kate, I'm going to make her time X minus 1/4, because 15 minutes is 1/4 of an hour. And I'm going to let Kate's time be the longer time because she got there after. Even though they left at the same time, she got there later. So her time I will expect to be larger than Ellen's, who is going faster and took her 15 minutes less, which is 1/4 of an hour. Again, they're going to the same location, therefore their distances will be equal, and I can set up the equation of 12 times the quantity, x minus 1/4, equals 9x. Again, if I distribute 12 times x is 12x, 1/4 times 12 will end up giving me 3, equals 9x. I'm then going to combine like terms by subtracting 12 from both sides, 12x from both sides. Okay, 12x from both sides. Remember, we're combining like terms here. And I'm going to end up getting two negative numbers, which I don't like to do, but it's the quickest way in this case. So we then have -3, and then we get -3x over here. We end up dividing both sides by -3, and we get 1 for our x. That represents 1 hour. If we go back up to our problem, Okay, we get 1 hour for X, which is Kate's time. So if she left at 3 o'clock, Kate's going to get to the library at 4 o'clock, and her friend Ellen will get to the library 15 minutes or 1/4 of an hour before Kate, which is 3:45. Hope this helps. Hi once again. We are looking at two boats traveling in the same direction. So we have Tom and Mary. Tom is traveling at 25 miles per hour, and Mary leaves after him and is traveling at 30 miles per hour. Again, the consistency with units is really important. We are told that Mary leaves the dock after Tom by 10 minutes. 10 minutes here is the important key component. So if we let Tom's time be T, Tom's time will be T for Tom, and T for Tom's time, Mary's time is going to be T minus 10 minutes. But again, we want to keep our units consistent, so 10 minutes is 1/6 of an hour. 10 over 60 reduces to 1/6. We can then set up our equation with equal distances, which is 25t equals 30 times the quantity t minus 1/6. Notice how the fractions and what we're multiplying them by will reduce rather quickly with most of these problems. Keeping your units consistent is really important to getting a solid equation and an accurate answer. Hopefully you can solve it from here. See me if you can't. Here we have our kite problem, and we're told that the tail of the kite is 1.5 feet plus twice the length of the kite. So the kite is much long, or the kite string is much longer, the tail is much longer, excuse me, than the kite. Together, they're going to be 15 feet 6 inches long. Again, unit consistency here is really important. With this problem, notice how they've stepped it out for you. Here is the length of your tail. Here's the length of the kite. So we end up getting the equation of x plus 2x plus 1.5. And again, that unit consistency is extremely important. And what that's going to equal is 15.5, because 6 inches is 1/2 of a foot. We can combine like terms. And then solve this two-step equation. Remember, the question is asking for the length of the tail. If you solve for x, you're actually getting the length of the kite, and then you need to compute to get the 10 feet, 10 inches, or 10 feet and 5/6 of a foot. So I hope this helps, and I'll see you in class tomorrow.